Here's a good practice problem for the SAT or ACT. If you'd like to try the problem on your own first, go ahead and pause the video and then type your answer in the comment section down below. Otherwise, let's go over it together. M and n are prime numbers. If the square root of 21 times m times n times 5 times 7 is a rational number, then what is m times n? For starters, it's good to review real quick how you get a rational number when dealing with radicals. Just say you had the square root of 9, that's going to be rational because you're going to end up with the number 3. Similarly, the square root of 64 is going to be rational because that's just going to be 8. If these are rational numbers, then what would an irrational number look like? The square root of 8 is irrational because if you go ahead and try to simplify it, you would end up with 2 root 2, and this would equal some decimal that goes on forever. Similarly, the square root of 45 you also can't write as a whole number or a rational number. You're going to end up with 3 root 5 if you go ahead and simplify this. This is also going to be a decimal that goes on forever, making it irrational with no pattern. The key difference between these rational radicals as opposed to the irrational radicals is that for the rational radicals, you can go ahead and break up that number inside the radical into a pair of primes. So for 9, we have 3 times 3, and for 64, we're going to have 6 of these 2's that are going to multiply together. So that's an even number of primes that all get paired together. For the irrational radicals, this isn't going to happen, and we're going to have an odd number of these primes, and we're not going to have pairs each time. So one of these 2's is going to be left out. Just like this 45, this breaks into 3 times 3, which do pair up, but this 5 doesn't have a partner. So the key here is that we're going to be looking for pairs. Notice how we have pairs over here. And then for irrational numbers, while we do maybe have some pairs inside, there's always going to be one number that's kind of be left on their own here. So in this case, the 2 and the 5. Now that we've gone over some background a little bit, let's take a look at the expression that we're working with. In order for this expression to be rational, we need to make sure we have pairs of these prime factors. 5 and 7 are already prime, so let's go ahead and take a look at this 21, which we can break up into 3 times 7. Breaking up 21 into 3 times 7, notice that we have a bunch of prime numbers now. So we can actually see that this 7 and 7 are going to pair up here, so that's going to make a perfect square. However, this 3 doesn't have a partner yet, and this 5 also doesn't have a partner. Let's go ahead and make sure we partner up this 3, maybe with this m over here. Let's go ahead and partner up this 5 with this n over here. If we make m equal to 3 and n equal to 5, our expression would look like this, where our 7's have partners, our 3's have partners, as well as our 5's. If all the numbers have partners, that means they will multiply to get perfect squares, and if you take the square root of the product of perfect squares, we're always going to get a perfect square, or a rational number. If you happen to flip the value of m and n, that doesn't really matter, because after all, we were being asked to find the product of this m and n value. So if you go ahead and multiply 3 times 5 or 5 times 3, we're going to get the same thing either way. So this is going to be equal to 15. We should go with answer choice B. If you found this video useful and you want to let me know, feel free to just go ahead and do so by clicking that like button.